Hi, in this video we are continuing our discussion of lesson 4-1 on absolute extrema and the mean value theorem. In this video we'll be discussing how to find the global extrema of functions when you're just given an equation. In the last video we defined these terms and tried it out on a picture. So when we are asked to find the global extrema of this function, it's a three-step process. The first step is to find the critical numbers of the function. To find the critical numbers of this function, we will need to find the derivative f prime of x. So by now you should be getting good with derivatives, and you should see that 3 times 1/3 will be 1, x to the 2. 2 times -2 is -4, x. So we will have two possibilities to find the critical numbers. The first, f prime of x equals 0. So we need to write this equation down. Do not skip writing this down. That will be true when x squared minus 4x equals 0, which would be x times x minus 4 equals 0, or x equals 0 or 4. The other possibility would be where f prime of x would be undefined. So noticing that this is a polynomial would show me that f prime of x cannot be undefined, so this is not possible. Never. So we go ahead and we write our critical numbers. 0, 4. And I want to take a minute to check, are both of these actually in the interval of interest? And in fact, 4 is not in the interval. Interval. So the only critical number we need to check is 0. So it's common to arrange this into a table. On one side we'll have our x values, and then on the other side we'll have our f of x values. F of x is the only way to get y values of this function. We will not plug in the values we have into f prime. That would be finding the slopes of this function. So we will want to check what 0, our only critical number, again, -1, an endpoint, and 3, an endpoint. So we want to make sure we always check the endpoints and the critical numbers. F of 0 is 0. F of -1 would be -1 cubed is -1, minus 2, 2 times -1 squared, which is actually -7/3. In this case, we will want to simplify all the way. We have to use these values to compare one another. And f of 3 would be 1/3 times 3 cubed is 1/3 times 27, or 9. 2 minus 2 times 3 squared, minus 2 times 9, 18, which is -9. So now we compare these y values, and we can see that the absolute maximum value of f is 0. 0 beats both the negative numbers. Resist the urge to call these maxima because they're larger in terms of absolute value. And the absolute minimum of f is -9. Now, this is only true on that interval. we could maybe extend that interval and find some larger values. We already know 4 could have been tested if the interval were only slightly larger. But this is how I would answer this question were it a test. Next, find the absolute maximum and minimum values of this function on this interval. So when we go to ask about f prime, we notice that we don't really have a good technique for finding the derivative of an absolute value function. Whenever we find ourselves at a loss to describe a derivative, a good solution is to graph it. This is especially true of absolute value functions. That's really your key to an absolute value function. So a simple thought should show you that this is the absolute value function if it was shifted 2 to the right. So we're talking about the V shape shifted 2 to the right. That is so curvy. Where this is 1, 2. So this shape, and many students have trouble with this on the Unit 3 test, this shape is easy to find the derivative of. F prime, the slope over here is 1. F prime of this interval would be -1. So +1, -1. At x equals 2, we have what is known as a sharp turn. So f prime of x equals 0, never. When it does exist, f prime is only ever +1 or -1. And f prime of x will be undefined when x equals 2 because of the sharp turn there. So our only critical number in this case is x equals 2. So we found all the critical numbers. Now our only task is to plug them in to the function along with our 2 endpoints. Always remember to throw in the 2 endpoints. F of 2 would be 0. F of 0 would actually be 2. This is what leads to some confusion. And f of 5 would be 3. Again, because of this linkage and because of sloppy work, some students forget that our absolute maximum, when we go to record it, will be 3. Because 3 is the biggest y value. We do not write 5. It's really confusing because 5 is the location of that y value, and it's bigger than 3, but we're talking about y values here. And the absolute minimum is 0. Done. Last, a hard example. Find the extrema of f of x equals this giant nonsense function. So our first step is find f prime in order to find the critical numbers. 2/3 times 3 is 2. X. 2/3 minus 1 is -1/3. Derivative of -2x is -2. Because we want to actually use this to solve some problems, we're going to rewrite the function. This is extremely important. Many students forget this step and instead start setting things equal to 0. I want to rewrite this function without the negative exponent. And notice that the -1/3 brings it under this 2, not both 2's. So now we have a function that's much easier to talk about and solve with algebraically. Our first step is to set this equal to 0 and find what kind of values we get. So 2 over the cubic root of x minus 2 equals 0. Add 2 to both sides. 2 over the cube root of x equals 2. A lot of students seem to struggle with this algebraically, but all we have to do is cross multiply, so to speak, and multiply both sides by the cube root of x. The cube root of x, if we divide both sides by 2, would equal 1. And then if we cube both sides, we get x equals 1, squeezed there at the bottom of this slide. So that will be one possibility. Second, we will consider about f of prime of x being undefined. So when we look at this definition of f, and that's f prime, and again, that's why it's so very important you don't just leave this. This lets you neglect certain things. When we have this, we would say, oh, if x were 0, we would have a problem in the denominator. It has a domain problem at x equals 0. F prime has a domain problem at x equals 0. So our critical numbers are 0 and 1. Do they both live inside this interval? Yes, they do. So finally, we have a more interesting setup. So I'll start with the endpoints this time. Sometimes if you start with the endpoints, you're less likely to forget about them. And then we bring back the critical numbers, 0 and 1. Honestly, you're likely to forget about both of them, or either or the other. Negative 1 to the 2/3 power is positive 1. Negative 2 times negative 1 is positive 2. You want to make sure you're being very careful when you're plugging this in, that you don't make a simple mistake. It's very easy to. Now this is the hard one, because there's no real way to simplify 3 to the 2/3 power. But I will say it's 3 times the cube root of 9, because we will be able to get a bound on that. F of 0 is 0, and f of 1 is simply 1 to any power is 1, just 1. Now, many students think now is the time to bring out the calculator. We have a way of getting a bound on this without needing a calculator, and that's important for when you're doing problems like this by hand. Specifically, at some point in your life, you were probably taught a way of finding out the square roots. And this was done by saying this square root is lower than this square root, because the arguments are lower, and it's bigger than this square root. And it's key that we are picking square roots that we can evaluate, because this shows me that 1 is less than the square root of 3, which is less than 2. So the cube root of 3 is some decimal number between 1 and 2. In this situation, we're using cube roots though. So looking at the cube root of 9, I could say, well, gee, what's a cube number, a perfect cube, that's slightly bigger than 9? So, since we have to go one less anyway, we'll talk about cube roots that are slightly less than 9 as well. So 1 cubed is 1, 2 cubed is 8. That'll be as close as we can get there. And then 3 cubed, way overshot it, is 27. And that's the next actually biggest one. So now we know that 2 is less than the cube root of 9, which is less than 3. So the cube root of 9 is some decimal number between 2 and 3. So that's already pretty good. Some people are able to solve this problem based on that. But now we're going to multiply everything by 3, because the cube root of 9 was multiplied by 3. So if we force a 3 in the middle here, I should have a 9, and I should have a 6. And then if we subtract everyone by 6, getting what we have over there, that's 6 outside, we find that this number is some number between 0 and 6. So we see firmly that this number is certainly less than 5, because it's less than 3, and it's certainly bigger than 0, which makes that our absolute max is going to be 5, and our minimum of f is going to be 0. Now, if you are allowed to use the calculator, if this was on the calculator section, I would of course make this a decimal as soon as possible. I'm just showing you here what would happen without the decimal, without a calculator. How could you estimate this without knowing the exact decimal value of it? The exact decimal is kind of a misnomer. So now you should be able to do most of the questions in the homework up to example 15. I would try those out now, making sure you can do everything as you go. If you have any questions, please ask me. Good luck. Have a nice night. Have a good day. Bye-bye.